There are a variety of things around us. All these things are made up of a material which scientists termed matter. The food we eat, the stones, the clouds, and even the air we breathe is made up of matter. The food, the stone, and the clouds have their own mass. Not only mass, they occupy the space. We know that the measure of amount of space occupied by an object is called the volume. So matter has mass and volume. Have you heard of Panchatattva? They are air, earth, water, fire, and sky. Ancient Indian philosophers have classified matter into these five, but modern day scientists have classified matter on the basis of their physical and chemical nature. Let's now understand what is the matter made up of. Let's do an experiment to understand with what substance the matter is made up of. Take 100 ml of water in a beaker, dissolve a spoonful of sugar. We can see that the sugar is getting dissolved in the water. Two different substances mix with each other, which means there is something inside the two substances which intermixes. We call them particles. The particles of sugar and particles of water intermixes with each other. But the level of water remains the same. Then where did the sugar particles go? The particles of sugar get into the spaces between the particles of water. Let's assume these are the particles of water and these are the particles of sugar. Like this, the particles of sugar get into the spaces between the particles of water. To get into the spaces of water, we can imagine that the particles of sugar must be very small. Let's do one more experiment which proves that the particles of matter are small. Take 100 ml of water in a beaker. Add 2 to 3 crystals of potassium permanganate. It is a purplish black crystal. It is used to clean the wounds. Potassium permanganate is used as a medicine for many skin conditions. When it gets dissolved in water, we will get a pink solution. From the first, take 10 ml of solution and add to the 90 ml of water in the next beaker. Again take 10 ml from this and pour to third and repeat this till the fourth beaker. Then we can see the color of the solution becomes light, but still we can see the color of potassium permanganate. From this experiment, we can conclude that 2 to 3 crystals of potassium permanganate contains millions of tiny particles. Due to the presence of these tiny particles, the color of potassium permanganate can be seen after many dilutions. From these two experiments, we understood that the matter is made up of particles and particles are very small. Now let's look into the characteristics of matter. Particles have space between them. In the first experiment, we diluted sugar in water. The particles of sugar got into the space between the particles of water. From this, it is evident that there is space between the particles. Particles of matter are continuously moving. Another characteristic of matter is the particle inside the matter are moving. Let's see some experiments. When we use perfume, the smell of perfume spreads in our surroundings. Have you ever thought why? The smell spreads as the particles in the perfume mix with the particles of air. The particles in perfume mix with the particles in the air. The air particles are moving. Like that, these perfume particles also move. Due to this motion of particles, the smell spreads. The same case is with an agarbatti. When a few crystals of copper sulfate is put inside the water, first the color spreads in the bottom. This is because the particles in the crystal are in motion along with the water particles. As the particles move up into the colorless water above, the whole water turns blue in case of this copper sulfate. If we put these crystals in hot water, the water color changes in a faster rate. The particles in the matter are continuously moving, and the energy of this moving particle is called kinetic energy. So the particle possesses the kinetic energy. As the temperature increases, this kinetic energy also increases. In all the experiments, the intermixing of particles takes place. The particle of one matter gets into the space between the particle of another matter. This intermixing of particles of two different types of matter is called diffusion. On heating, this diffusion happens in a faster rate. Particles of matter attract each other. We discussed that matter is made up of particles. For example, if we take an iron nail and try to break it, will it break so easily? No. The reason behind is that the particles in iron nail are very close to each other. These are the particles in iron nails. They are very close to each other and they are held together by a force. But we can cut a rubber band easily compared to an iron nail. The particles are not held so tightly in this rubber band. The particles are held together by a force. In other words, we can say the force between the particles in rubber band is less compared to the force between the particles of iron nails. Till now, we discussed the characteristics of particles as there is space between the particles and particles move continuously and particles of matter attract each other. Now, let's learn about the state of matter. From smaller classes, we have been studying that matter has three states: solid, liquid, and gas. Matter has these different states due to the differences in the characteristics of particles. Solid state. We can name a number of solids like stone, pen, a book, a piece of wood. All the solids have a definite shape and volume and mostly they are rigid. Imagine this is a solid and here the particles will be very close to each other and they are held together by strong force. They vibrate in their own places but do not move from their position. They may break under force but it is difficult to change their shape. A rubber band is a solid which changes its shape by stretching, but it will come back to its original shape when the force is removed. When sugar is put in a jar, it takes the shape of that jar. But if you observe carefully, we can see that the shape of a single sugar crystal will not change. A sponge is a solid, but because of the air holes in it, air is trapped inside it. When we press it, the air will escape out. That is why we can compress the sponge, we can squeeze the sponge. But its original shape remains the same when the force applied stops. From this, we can conclude that solids have definite shape and solids are rigid. Examples of liquids are water, oil, milk, etc. When we keep them in a container, they will take up the shape of that container. Imagine this is liquid and here the particles will be far away, not so close to each other, but still they are held together by a force. They are not rigid and can change their shape as the particles in the liquid are not so close to each other as solids. A few minutes before, we discussed an experiment where potassium permanganate, which is a solid, diffuses into water. Oxygen, which is a gas, can diffuse into liquid. This diffused oxygen in water is used by aquatic animals for their survival. So now we know that liquids, gases and solids can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids as there are more space between the particles of liquid when compared to the solids, and the particles in liquid move faster than that of solid. Liquids have low density than solids. Mass per unit volume of a substance is called density. That is amount of matter in a given volume. Density is the number of particles in a given area. We know that particles in solids are close to each other and particles on liquids are far away. So this is a given area and this is a solid and this is a liquid. In this given area, the number of particles in solids is very high. So the solids particles are very close to each other, but in liquid the number of particles are very less as they are far away. So when we look into this, in a given area, the number of particles in solid is very high than the number of particles in liquid. So if we take a certain area and check the number of particles in that, surely the solids have more number of particles as they are tightly packed. That means the density of solids are more than liquids. The things that have high density will sink in water and the things that have low density will float on water. Ice is a solid, but ice float on water. How come is this possible? Let's check. In ice, the particles are arranged in a special manner. The water molecules in ice are farther apart than the water molecules in liquid water. Due to this, the density of ice is lower than that of water. This is the reason why ice floats on water. In gases, the particles are far away than liquids. Imagine this is gas in a given area and the particles are far away. But still they are held together by a force. Due to this, we can compress gas. That means we can squeeze or press the gas as there are large amount of empty spaces between the particles. Liquid petroleum gas which we use in kitchen is compressed inside the cylinder. CNG, which is the compressed natural gas, we use as a fuel. The oxygen cylinders which we use in hospitals contain compressed gas. Earlier we saw how we get the smell of perfume. The particles vibrate with greater speed and due to the high speed of particles and large space between them that help a gas to diffuse or intermix very fast into other gases. The particles in gas move very fast and they collide with each other. The particles in this gas, they collide with each other and they hit the container walls also. When they hit the container wall, a force is exerted on the walls. This force exerted by the gas particles is the reason behind the pressure exerted by a gas. You might have noticed when we pump more air into a balloon, the pressure goes up. This is because more gas particles hit the walls and more pressure is there. We know that water exists in three states: solid, that is ice; liquid, that is liquid water; and air, that is water vapor. Let us see what are the changes that happen during the conversion from one state to other. Take 150 gram of ice in a beaker. Suspend a laboratory thermometer so that its bulb is in contact with ice. This is laboratory thermometer and this is the bulb. This bulb is in now contact with the ice. Keep the beaker on flame. Note down the temperature when ice starts melting. When we give heat, the ice starts to melt. We know that there is a force which helps to hold the particles together. When the solid particles get heated, their kinetic energy increases and they start to vibrate with great speed. When the temperature rises again, the particles' energy rises and they will be able to break the bond between the particles. When the bond is broken, the particles start to move from their original position. The particles will start to move from their position. They are free now and they can move from their fixed position. When all the particles in the solid start to move around by overcoming the force of attraction, the solid changes into liquid state. That is, ice turns into water. The minimum temperature at which a solid becomes liquid at the atmospheric pressure is known as the melting point. The melting point of ice is 273.15 Kelvin, that is 0 degrees centigrade. That means at 273.15 Kelvin or 0 degrees centigrade, ice starts to melt and becomes water. The process of melting is called fusion. Fusion is the process in which a solid changes to liquid. When we observe the temperature carefully, when we observe this temperature, that is at 0 degrees centigrade, the ice starts to melt. But after that, there is no increase in temperature till the whole ice melt, even though we continue to heat it. What could be the reason behind that? We just discussed that to change a solid into liquid, the particles should break the force of attraction between them. After reaching the melting point, the heat energy we supplied is used by the solid particles to break the bonds between them. This is the reason that there is no increase in temperature. The heat energy supplied is hidden, and this is called the latent heat. Latent means hidden. The latent heat is absorbed by the particles of a substance during the change in its physical state. The amount of heat energy required to convert 1 kilogram of solid into liquid at atmospheric pressure at its melting point is called latent heat of fusion. We already discussed that fusion is the process of melting. At 0 degrees centigrade, the water molecules have absorbed the latent heat and they have more energy. But at 0 degrees centigrade, the ice particles are yet to absorb the latent heat and they have less energy. Now let's check what happens when water changes into gas. When we give heat energy to water, the kinetic energy of the particles increases. When we give this heat, the kinetic energy of these particles increases and they start to move faster. At certain temperature, the particles of water get enough energy to break the bonds between the particles and they start to move freely from their fixed position. Finally, water changes into gas. The temperature at which a liquid starts boiling is known as the boiling point. Boiling point of water is 373 Kelvin, that is 100 degrees centigrade. Like latent heat of fusion, we can define latent heat of vaporization. It is the heat required to convert 1 kilogram of liquid into vapor without a change in the temperature. There won't be any temperature increase in the system since a liquid starts to boil until the whole liquid changes into vapor. The heat energy provided is used by the particles of liquid to break the bonds between them. We have seen that first a solid change into a liquid and then to gas. But there are some solids which directly change into gaseous states. Let's understand that. The conversion of a substance from its solid state into gaseous state without passing through liquid state is called sublimation. Have you heard of dry ice? It is actually frozen carbon dioxide. It directly turns into gas at minus 78.5 degrees centigrade. Camphor is a solid that converts directly into gas. It sublimates as the temperature at which it turns into gas is much less when compared to their melting point. When a gas directly changes into solid, that is called deposition. One example of deposition is water vapor changes directly into ice without becoming a liquid. This is how frost is formed. Frost is a small ice crystals formed on the ground or any other surfaces. When water changes from its gaseous form into liquid form, we can call it condensation. Most of you might be familiar with morning dew on grasses. When air comes in contact with the surfaces which are colder than air, like grass, the particles of gas become less energetic and they come close to each other. And it will come into a point when the air changes into liquid form. This is what we see as morning dew. At a particular temperature, not all the particles have same kinetic energy. For example, imagine this as a bucket and water is filled in the bucket, and this is the surface of the water. All the water molecules inside it don't have the same kinetic energy. The water molecules or the water particles at the surface have more kinetic energy compared to others. They will vibrate with great speed and they are able to break the bond between the particles and move freely. Now the liquid changes into gas. This phenomenon happens without applying pressure or heat. That means before reaching the boiling point, the liquid changes into gas. This is called evaporation. We can see a number of examples in our daily life, like uncovered water slowly changes into vapor, that is evaporation, and wet clothes dry up, that is also evaporation. Now let's check what are the factors affecting evaporation. Increased surface area. If surface area is increased, evaporation also increases. That is why we spread the clothes while we keep them for drying to increase the surface area. Increase in temperature. When temperature rises, the kinetic energy of particles increases and liquid changes into vapor. Decrease in humidity. The amount of water vapor present in air is called the humidity. Air cannot hold more than a definite number of water vapor at specific temperature. This is air. There is a limit of water vapor that air can withstand. So if the amount of water vapor is already high, it cannot afford more. If we try to dry clothes in high humidity, the air in the surrounding is not in a position to hold more water vapor. The water particles from the wet dress cannot evaporate and they won't dry so easily. As a result, the rate of evaporation decreases. When humidity is decreased, the rate of evaporation will increase. Increase in wind speed. Have you observed in a windy day clothes dry in a faster rate? The particles of water vapor moves away with wind. It decreases the amount of water vapor in the surroundings and air can afford more water vapor. Thus evaporation increases. Evaporation causes cooling. During evaporation, some amount of energy is lost from the liquid particles. These liquid particles absorb the energy from their surrounding. This causes a decrease in the temperature in the surroundings. That means the surroundings becomes cool. Girls might be familiar with nail polish remover. It is actually acetone. When we apply this acetone on the nail, we get a cooling effect to our nails. This is because the acetone particles drain the energy from our palm to evaporate. During summer, we sweat a lot. Sweating is a mechanism of body to maintain temperature. During evaporation, the liquid particles in sweat gain energy from our body to evaporate and thereby giving a cooling effect to our body. Cotton cloths can absorb the sweat and expose it to the atmosphere for easy evaporation. This is the reason we always use cotton clothes during summer. That's it about matter. If you like this video, please share it with your friends. If you have any queries, put it in the comment box. Thank you.